Hello everyone. Welcome to this module on Amazon RDS Backup, Restore, Security and Cloning. On behalf of the Cloud Expert Solutions team, I would like to thank you for joining us and exploring this video. For your Solution Architect Associate certification, a deep understanding of these topics is not just a best practice, it's a necessity. You must know how to protect data and ensure business continuity. In this module, we'll dive into RDS's core backup mechanisms, followed by process to migrate on-premises MySQL and PostgreSQL databases to Amazon RDS or Aurora cloning capability. Then we'll dive into the way to implement multi-layered security controls. This knowledge is key to building resilient and secure database solutions. Before concluding the video, we'll provide required certification based practices and tips. Without further delay, let's get started. Let's start with the RDS backups. As Aurora is one of the database engines available in RDS, we'll start with RDS backup and restore features. RDS offers two primary methods. First, automatic backup. These are enabled by default, and RDS performs a daily backup during a defined backup window, which is called maintenance window. RDS continuously uploads transaction logs to Amazon S3 after every 5 minutes. Combination of transactional logs and automated daily backups allow restoration of a database instance to any second within the specified retention period and up to the least restorable time, typically the last 5 minutes, and this feature is called point-in-time recovery. RDS's automated backup retention period can be configured from 1 day to a maximum of 35 days. Setting the retention period to 0 days means you are disabling the automated backups. If you are creating the database instance via AWS Management Console, then the default retention period will be 7 days. However, if you are creating the database using RDS API or AWS CLI, then the default retention period will be 1 day. Now let's review the manual backup options. For manual backup, you can take manual snapshots as needed, which will offer more control over your backup strategy. Manual snapshots persist until explicitly deleted and are not subject to automated retention period. Please remember, for manual snapshot, there is no retention period unless and until you are manually deleting those backups will be with your account. Manual backups are useful for meeting long-term data retention requirements such as those for compliance reason. If you have more than one database instances in your database cluster, then after taking a manual snapshot, it will capture the entire database cluster, not just for a single database instance. While the first snapshot is a full copy, however, subsequent manual snapshot of the same instance are incremental, and it is going to save only the data that has changed between the two snapshots. Aurora is a cloud-native AWS proprietary database offerings, and it's a database engine from RDS. That is why Aurora supports all the default RDS backup and restore capabilities. However, Aurora backup and recovery features are more advanced than standard RDS backups. And let's review one by one. To start with, backtrack. Aurora allows you to rewind your database to any point in time within the configured period up to 72 hours without relying on traditional backups, and this way you can minimize data loss from user errors. Just like a videotape, you will be able to rewind the cassette and replay, the same feature available for Aurora. Next, clustering and copy on write. Aurora creates cluster level backups, and with its copy on write protocol, you can create a new cluster that shares the original cluster's data volume. Please remember, only change blocks are copy, which will make cloning extremely fast and efficient. If you have a requirement to create a staging environment, then Aurora cloning is the best option, and we have a dedicated section to cover Aurora cloning at the later half of this video. The other features are continuous data protection. Aurora's architecture enables continuous data backups, and it will ensure that your data is always protected with a user-defined retention period up to 35 days. Aurora's native point-in-time recovery operates without impacting the performance or availability of your database. And last but not least, standard RDS backups are at the instance level, while Aurora backups at the cluster level, which will encompasses all the instances within the cluster. Now, if you have an on-premise MySQL or PostgreSQL database, then how can you migrate that to Amazon RDS or Aurora? You cannot directly restore an on-premise backup file like .bak or .sql file to an RDS or Aurora instance using your simple restore command. The primary methods of migrating an on-premise database to RDS are one of the two. Either you can use logical migration and you can use tools like MySQL dump, or you can use assisted migration using the tools like AWS Database Migration Service or AWS DMS. Now let's review one by one. To start with method number 1, using native logical tools, that is MySQL dump for MySQL engine. First, we export the data from our on-premise database, and as we mentioned, we can use a tool like MySQL dump and we can create a logical dump file for our database. Then we can upload the dump file to Amazon S3. After that, we can create one RDS or Aurora database instance. This will be your target database. While creating the new RDS or Aurora cluster, it should be compatible with your source database engine. And the last step is restoring the data. You can use a client tool like MySQL client from an EC2 instance, which will be in the same VPC, to connect the new RDS or Aurora endpoint, and it will restore the data from the S3 file. This method is offline migration, and it is suitable for smaller databases and if you have a planned migration with acceptable downtime. The other option is assisted migration using AWS DMS, which is online migration and you do not need a downtime. Let's review the process. Let's assume here is our on-premise MySQL database. The first step is you need to create an AWS DMS replication instance, which is nothing but a server that runs the migration task. You need to create the target endpoints, that means where your database will be restored, which is nothing but your Aurora or RDS cluster. And then you can configure the source, which is your on-premise MySQL database, and target your newly created database in AWS. You need to configure that in DMS. Then you need to create run and migration task such that DMS can perform a full load of existing data and optionally replicate all ongoing changes, which is called change data capture or CDC, and it will keep your database in sync until you cut over. If you have a secure database or if you have sensitive data, optionally you can create VPN connection or direct connect connection between your on-premise and AWS cloud, which will provide you a dedicated or a secure channel between your AWS environment and on-premise data centers. And once the replication is completed, you can point your application to the new database or the database in AWS and you can perform a cutover. Next, we are going to review database cloning feature. For our day-to-day application development work, majority of the time we need to create a production copy of our data for different testing purposes. In traditional way, we always take a backup of the production database, then restore the backup as non-production database, as we can't compromise the integrity of the production data for any testing activity. As you know, this process is painfully slow and the duration depends on the database volume or the data volume of the database. Aurora resolved this issue using Aurora cloning feature. Amazon Aurora allows you to create a complete, ready-to-use copy of an existing Aurora database cluster in minutes, regardless of the database size. It is significantly faster and more cost efficient than a traditional snapshot and restore process because it takes advantage of Aurora's unique decoupled storage architecture. Here is our Aurora prod cluster. Let's review how Aurora cloning works. When a clone is created, the new Aurora cluster shares the exact same underlying distributed storage volume as the original source cluster. Please remember, at the beginning, no data is copied, so the process is near instantaneous. Both the source and the clone cluster reference the same data pages. Now, because of the shared storage, there is no additional storage cost when the clone is first created, but your production and non-production applications will write data post-clone creation, and that time the diversion will start. As data is modified, either the source or the clone, Aurora uses a copy on write protocol. Instead of overwriting a shared data page, a new copy of that page will be created for the cluster which is making the change. Let's understand with an example. Let's assume these are our data copies that our non-production application and production application has created. Now the changed cluster will update its pointer to reference the new data pages, whereas the unchanged cluster continues to reference the original shared data pages. After the clone is created, the source and the clone clusters are completely independent and changes made to one will not affect the others. In terms of benefits, some of the key benefits and use cases are: if you want to create test environment, we have already reviewed the example. The other is performance testing. You can conduct load testing or performance benchmarking on a clone to ensure the changes won't affect your production workload. Another one use case could be if you want to debug any production issue. That means developers can get a clone of production data for the debugging purpose. With this approach, we are not exposing our production data directly to the developers, and the production data will not be corrupted with any test data. Next, we are going to review multi-layer security approaches for databases. As you know, security is paramount for databases, and you should implement a layered security approach for RDS, Aurora, or even for any production databases, which is a key topic for this certification exam. To start with, network security. First, always place your RDS or Aurora or any production database in a private subnet within your VPC. Using database security group, you can filter all other accesses and you can only allow access from your application servers. You can also use network ACL or network access control list for additional stateless layer of security at the subnet level. Next, in terms of encryption, you must protect your data both at rest and in transit. And encryption at rest is performed using AWS KMS, and you should enable encryption while creating any production database. If encryption is enabled at your database, then it will automatically encrypt snapshots, backups, and read replicas. Encryption in transit is achieved using SSL or TLS certificate to secure the connection between your application and the database endpoint. Before concluding the video, let's review some certification best practices and tips. You should understand the different use cases for automated versus manual snapshots. You should remember automated snapshots are for point-in-time recovery, while manual snapshots are for long-term retention. AWS always recommends you to place your RDS or any production database in private subnet, and you should disable public access. So if you see some options in the AWS certification to keep the database in public subnet or enable public access, please review those use cases. Most likely, those are the destructor and not the correct answer. All the AWS database offerings comes with encryption at rest and which is enabled by default. Once the encryption is enabled in your database, you can't disable encryption. Any snapshots, backups, and read replica of your encrypted database will be always encrypted. And last but not least, please remember to convert any RDS MySQL or PostgreSQL to Aurora MySQL PostgreSQL. You don't need any data migration. You can directly convert that using read replica. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.